All right, welcome, folks. Our timing is good. I think the post is up in the classroom. I'm a little surprised we don't have more people in right now. I might just wait another 30 seconds or so just to let some other people join the stream. And then we will get started. All right, well, we're a couple minutes after 11, so I'm going to start anyway. So welcome to the 22nd day of remote learning. Today's joke is, what is a pirate's favorite letter?
R.
You'd think so, but to me first love be the sea. Thank you very much for your help with that. All right. So our terrible joke of the day brought to you by the internets. Happy Friday. Simplify that like button to show your support. Today's featured YouTuber is Mark Rober. He used to work making robots for NASA and now puts out one video a month. So he's not a very frequent YouTuber, but these videos are pretty fantastic. He builds some awesome things for them. One of his videos about a porch pirate trap went viral, and it's a pretty useful video for these days where a lot of people are ordering things online. So check it out in the lesson. A quick reminder of two things. One, the summer school upgrade course is happening. If you are interested in doing some more advanced functions practice and upgrading your skills, please talk to your guidance counselor about that. And the second one is for those of you who are scheduled to do an assessment this afternoon at 2 p.m., please make sure that you have your camera set up, tested out, so that you know that you can communicate and that you'll have a way to take a picture of your math work if you're doing it on paper. You're also welcome to do it in Google Docs, whatever is most useful to you. All right, so let's dive right into our lesson for today. So in the classroom, you can see that we have a link to the modeling page. We're going to go through and do one, maybe two of these, and then I'll give you a chance to finish the rest up. So let's get started. All right. So if you can just type a 1 in chat if you can hear this. Just want to make sure that everything's working properly, and then we'll get moving. All right. So let's take a look at the first question. So this one, we have a Ferris wheel, and it is set 4 feet off the ground. So distance from the ground to the Ferris wheel is 4 feet. Has a diameter of 26 feet. And I'm going to put the diameter up and down just because that's going to be useful to us here. And it rotates once every 32 seconds. So the period of rotation is 32 seconds. So we're asked, if we begin the ride sitting in a chair that is 6 feet above the ground and rising, how high will we be in 10 seconds? So 10 seconds into the ride, how high will we be? So assume there's some platform here, 6 feet off the ground. We start there, and then we rise for 10 seconds. How high will we be? So in order to figure this out, we basically need to set up a model of the movement of this point around the circle. And since it's a unit, or since it's a circle, we know that the movement around it, the x coordinate is like cosine, the y coordinate is like sine if we start here. So that's our unit circle model. So we're going to set this up. I'm going to use a sine function. You could also do this with a cosine function. So I'm going to say f of x equals, and then we know we have a sine bx minus h plus k. So that's our general overall model, and we just want to fill in these different things. So a we know is the amplitude. Well, the middle of the circle up to the top or down to the bottom is going to be our amplitude. It's 26 feet across the circle, so we know that the amplitude is going to be 13. From this midpoint, the highest you rise is 13 feet higher, the lowest you go is 13 feet lower. So our amplitude is 13. And then we have sine of the period. And we know that b comes from the period, but it's not just the period itself. So if we have the period, then we know that 2 pi, if we're dealing in radians, if we were dealing in degrees, this would be 360. And we divide that by the period. So our period here is 32. So let's walk through why it works that way. So first of all, remember that when we're dealing with the transformations to the x coordinate, because they're inside the sine function, we have to do things backwards. So we're subtracting off instead of adding for the translations, and we're going to have to divide by instead of multiply by for the stretches and compressions. So here, if we want to multiply by 32, like if we had a period of 1 second and we wanted to stretch it to make a period of 32 seconds, we would have to divide by 32. But the fact is that we actually have a period of 2 pi. So one way to think about it is we start with 2 pi, we want to multiply it by 1 over 2 pi, and then by 32 to get a new period of 32. But since everything's happening backwards, instead of multiplying by 1 over 2 pi, we're going to multiply by 2 pi. And instead of multiplying by 32, we're going to multiply by 1 over 32 because the transformations are backwards. And so that is the same as multiplying by 2 pi over 32, which is why, blurry, there we go, which is why 2 pi over 32 is what we need as our value for b. And by the way, a lot of people kind of memorize how this works. I do have it in my memory now because I've done it so many times, but I don't try to memorize it. This is usually how I go through it. And if I haven't done these questions in a while, then I often have to actually just go through this again and be like, okay, yeah, it's going to be 2 pi divided by whatever scaling factor I want. Okay, and then in here we have x minus h, and h is however much to the left or right things are changed by. So I'm going to leave that for now and come back to it in a moment. K is the vertical translation, and you can also think of it as the axis, the middle axis of the sine function. Well, the middle of the sine function is going to be right here. We know this is 13 feet. This is 13 feet. So we have 4 feet plus another 13 feet to get to the middle height of the wheel. So that means we need to add 17 feet here in order to get up to the correct height. Okay. All right, so the last piece is the offset. So normally, if we were doing a sine function, we start in the middle and we go up and then down and then down and then up. So let's draw that out. Sine function, we start in the middle, we go up and then down and then down and then up to get our full rotation. But in this case, we're starting a little bit farther back. We're actually starting not here where we go up, down, down, up, down, down, up, but we're starting here, somewhere in here, where we're going to go up, down, down, up. But our first up isn't a full quarter. There's a little bit more behind it. So we want to move this function to the right by whatever distance this is. However far this is, we want to move it over so that it becomes our 0 time. So we need to figure out what distance that is, or another way to say it is we need to figure out what angle this is, because the angle is going to let us figure out the time. All right. So this is the tricky part of this question. How do we figure out this angle theta and get from it the time? Well, we could figure out the coordinates for this point and for this point and use them to get us an angle. All right, so let's take a look at it. So how do we figure out where this is? Well, it's going to be 6 feet above the ground, right? We know the full bottom's at 4 feet. That one's at 6 feet. And we actually know this one too. This is at 17 feet above the ground. So take a moment, think about how would you find coordinates for this point right here, or how would you find this angle? Give you about 30 seconds to think that one through. All right, so hopefully you've had a chance to kind of think it through. There's a few different ways to do this, and I probably don't have all of them in my head, but when I look at it, I think, okay, let's think about that unit circle. So this part here is going to be 0 on the y-axis for our height. And this point here is going to be at -1. So 0, -1, +1. So I'm going to think about scaling this circle down to that size. So the first thing is to redo the translation. So this 6 feet, it's 6 feet above the ground, but if this point is 17 feet above the ground, that means that this is actually 11 feet down from the axis. All right. So if I'm trying to find a coordinate of here relative to the center, I can think of it, okay, it's 11 feet down from the center. So my y coordinate is like -11. And I want to shrink that, right? Because we don't want this big 13-foot radius circle. We want a 1-foot radius circle so that we have a unit circle. So I would need to shrink this circle from 17 feet down to 1 foot. And that means everything shrinks by a factor of 1/17. So if I'm on the unit circle, this is the y value that my point here is going to have. So the corresponding point here is going to have an x value, which we don't know, and a y value of -11/17. But we know that the y value is the sine of the angle. So we've got a y value of -11/17, and that is equal to the sine of our angle. And so now we can solve this trig equation and figure out our angle. So I'm going to pause. I'm going to do the calculator work. But while I'm doing that, if you have questions about what I've done so far, go ahead and ask them. This little piece here of how to find the value for h, people often find it very tricky, and we're not even done yet. But what we've just done there, people often find that pretty confusing. So if you have questions about it, let me know. Even if you just want me to repeat and go over the explanation, very happy to do that. Realize my calculator is not in degrees, or is in degrees, pardon me. We want radians. Okay, so sine inverse of negative 11 over 17, close, and we get theta equals negative 0.704 approximately radians. All right. So now that I know how many radians, I go back. I need to translate that in terms of seconds, right? So I have an angle, but I need to know the angle in terms of seconds. Fortunately, we've already done the hard work. We've figured it out right here. If I have an angle of 2 pi, that's a full rotation, which is the same as 32 seconds. So we have negative 0.0 or negative 0.704. Just going to make sure we can see here, over 2 pi equals what out of 32 seconds? And obviously we just multiply both sides by 32 here to solve this. So we'll get 32 times my answer divided by 2 times pi. And please make sure you have brackets around the 2 pi because we want to divide by the entire 2 pi. We don't want to divide by 2, take the answer of that and multiply by pi. So bracketing pretty important here. So x is equal to negative 3.584 seconds. And so that tells us our offset. Okay, so what questions do you have about that? All right, give me a 1 in the chat if that's making sense. And if you have a question, please go ahead and ask it. Thank you, Rumaisa. Going to wait a few more moments. I see we've got at least one other person here. Okay, so if you're still typing a question, please go ahead, finish it off. We're now going to put together what we have here, which is that the height, and I maybe shouldn't have used F, I should have used H up there. So I've just changed the F to H because of height. So height at time X is equal to 13 sine 2 pi by 32 of X plus 3.584 plus 17. Okay. Thank you, Danielle. So now I always try to check whenever I have a modeling equation. I'd say, okay, I want to check. And I know that at 0 seconds, I should be 6 feet off the ground. So I'm going to find the height at 0 seconds by subbing 0 in. So I go 13 times sine of 2 times pi divided by 32 times 0 plus 3.584 is just 3.584. Close the brackets on the sign, plus 17. And I get 25. And that is some bad news. And the reason it's bad news is that I should have had just 6. So where did I mess up here? So it's plus 17, so that's reasonable. I'm adding, just going to move us left. Let's pull it up in Desmos. So this is the other tool here. You run into trouble, you can map what you've got in Desmos. F of x equals 13 sine of 2 pi over 32 times x plus 3.584. Close all my brackets, plus 17. So I can see the model here in Desmos. It looks good. So obviously, unfortunately, I'm not sure how to do screen share with you, and it's on my regular computer. I probably should have done it on my Chromebook so I could show you. But if I'm looking at this equation put into Desmos and graphed, I can see a lot of good news. So first of all, it maxes out at a height of 30, and the minimum height is 4, which is exactly what we would expect from our diagram here, right? 4 feet is the minimum height, 4 plus 26, that's 30 feet, which is the maximum height. Oh, and I think I might be seeing the problem. So at times 0, this is up at 25. I think, is that a sign error with the transfer? Oh. Interesting. Okay, so it looks like this number here may be off. So I'm also seeing that we have a period length of about 32. So that tells me that this number, and this number are correct. And so I've narrowed in, it's got to be a problem with this one here. And what if I go to 0? Okay, so just doing a little bit of testing, playing around in Desmos, it looks like this number should be closer to -5. So I'm going to see if we can figure out how we got that one messed up here. All right, so let's look back at our unit circle. So we're trying to shrink this larger radius circle, this 13-foot radius circle down. Oh, and that's what it is. I use 17, which is the height, and it should be 13. Okay, cool. There we go. So let's redo this calculation. Sine inverse of -11 over 13. Oop, better type it in correctly. So instead of -0.704, we get -1.0087 radians. And so that'll replace this here, -1.0087. And so then if we do that, divided by 2 times pi, and again, make sure you get your brackets around the 2 pi, and then times the result by 32, we'll actually get an x value of -5.137402. And that should give us a good situation. So there you can see the importance of doing a test. Once you've created your model equation, always test it with a value you know to make sure that you got it right. It would have been not so fun if I'd gone through and did a whole bunch of calculations, got a whole bunch of answers thinking they were correct, but in fact had an error in my model. So now we're going to retest the model. H of 0 equals 13 times sine of 2 times pi divided by 32 times x, which is 0, plus, and now it's not 3.584 anymore, it's 5.137402. So 5.137402. Close both sets of brackets, plus 17. And now I'm getting 28. What did I do? Does I need it? Oh, I did a addition and should be a subtraction. Okay. Minus. Hey, there we go. So you can see now that we've got it right. We get a 6 there. And so we know that our solution is correct. All right. So again, two things to emphasize. One, once you've made your model, please give it a check. And the second one, that if you find that the model isn't working right, put it into Desmos so that you can see the graph, because in the graph, you'll easily be able to see, do I have the right period? Do I have the right amplitude? Do I have the right, all of the different parameters here? And you'll be able to narrow in on where the error is. Okay, so now we can get back to our question, which is, how high will you be 10 seconds into the ride? Well, now that's easy to do. We just do h of 10. Let me make sure I'm still on screen here. Yep. Okay, just do h of 10. Plug that into the calculator. So that's 13 sine of 2 pi by 32 times 10 minus 5.137402 plus 17. And the calculator for that is 13 times sine of 2 times pi divided by 32, close bracket, times, open the bracket, 10 minus 5.137402, close the bracket, plus 17. And so we get an answer of 27.6 approximately. And that is in feet. So therefore, after 10 seconds, let me just make sure I'm on screen here again. Pull that a little higher. So after 10 seconds, you will be 27.6 feet in the air. Okay, so I'll pause there. If you have questions, let me know. And if you have no questions, please just put a 1 in the chat. Cool. Thank you, Daniela. Okay, so let's look at part B. During the first minute, when will you be 20 feet high? All right. So we know that we want height to be 20. We need to go through and solve that equation. So 20 equals 13 sine 2 pi by 32 times, x minus 5.13742 plus 17. So we'll just isolate the sine part here. Let's subtract 17 from both sides. We'll get 3. Divide both sides by 13. And then over here we end up with sine of 2 pi by 32 times x minus 5.13742. And then we can apply sine inverse to both sides, and we'll get sine inverse of 3 over 13 equals, that's going to be our angle, which is what's here inside the sine. So 2 pi over 32 times x minus 5.13742. Get ourselves a bit of extra space here to work with. So we have divide both sides by 2 pi over 32, which is the same as multiplying by 32 over 2 pi, the inverse, times sine inverse of 3/13. And then we will have had this part left, x minus so on. So we're going to add 5.13742 or 402, and that will equal to x. So we've solved the equation here, and we just need to put this into our calculator to get a conclusion out of it. Just going to get that paper held a little bit better. Okay. So calculator, 32 divided by 2 times pi. And notice again the brackets. By far the most common question that I get from students is, why isn't this working? And when I look, it's that they've just forgotten the brackets around the 2 pi. We have to divide by the whole 2 pi, not just the 2. All right, and then times sine inverse of 3 over 13. Close all the brackets there and add 5.13742. And we get x equals 6.3233 and approximately 9 there. Okay. So this tells us that 6 seconds in, we will be at a height of 20 feet. But we need to be a little bit careful, because the question is actually during the first minute, when will you be 20 feet high? Well, during the first minute, we know that we're going to be at 20 feet a few different times, right? Because if we think about what our path looks like with height and time, so there's time, here's height. So we start 6 feet above the ground, we're going up, we max out, we come back down. We come back down like this, get a little lower than 6 feet before we go back up, and so on. The spot when we've completed a full rotation is only 32 seconds later, right? The period of this function is 32 seconds. It takes 32 seconds for the wheel to go all the way around. So we'll go up to the top of the wheel, come back down, bottom out, and then start rising again, ending up at 6 feet and rising 32 seconds later. and then we're going to do it all over again. All right, so this is not the world's most beautifully drawn sine function, but we can see after 64 seconds, 2 rotations of 32 seconds, we'll be back at that same spot again, 6 feet off the ground and rising. So we found out this point here, which is that at about 6.3 seconds, we are 20 feet off the ground. But we can see that within the first minute, there's going to be another one there. That's before 32 seconds. Shortly after 32 seconds, it's going to happen again. And then it looks like this one will probably also be within that first minute. So we actually have 3 more of these to track down. All right, so let's take a look at this one here. Once we have these two, those two are very straightforward to get. This one's not too hard either. So it's worth thinking about the sort of 90-degree mark here. So these are both going to be symmetric with each other on either side of this maximum marker. So if we can figure out where this maximum position is, we can just go back to 6.3, figure out that distance, and then flip and go the other side to get the spot where we are for this one. So we want to figure out the maximum. We know that the sine function is going to have its maximum when x equals pi by 2, right? Because sine starts at 0 for a regular sine function. It starts at 0. It goes up. It ends up at 1 when x is pi by 2. Comes back down to 0 when x is pi. And then it goes back to -1 when we have 3 pi by 2. And then at 4 pi by 2 or 2 pi, we've finished a full rotation. So 0, pi by 2, pi, 3 pi by 2, and 2 pi. Or another way to think of this is 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, so we want to figure out where is, for our transformed function, where is this maximum going to be? And we know it's going to happen when what we have inside is at pi by 2. Well, what we have inside the sine function, that's 2 pi over 32 times x minus 5.137402. And we know we want that to be equal to pi by 2. So we want to find out what time we get the maximum angle and therefore the maximum height. Or we get a 90-degree angle and therefore the maximum height. Okay, so we can divide both sides by pi. That gives us a nice cancel. 2 over 32, that's 1 over 16. Multiply both sides by 16, we'll get 16 over 2, which is 8. And over here we have x minus 5.137402. We can add that to both sides. 8 plus 5 is 13, so this is going to be 13.137402. So that is our maximum time. So if we found that this spot here is 6.32339, then we know that we're going to hit the maximum at 13.13 seconds. So therefore, the distance between those two, distance is 13.137402 minus 6.32339. Plug that into the calculator. 0.137402 minus 6.32339. Whoop, I clearly missed a decimal point somewhere in here. Oh, there it is. Insert decimal point. Oh. Okay. And we get 6.814012. So now we know that this distance here is 6.8 approximately. And so if we add it on to our maximum spot, we get the position of this second value. So x2, our second value, is going to be 13.137402, the x value of the maximum, plus this extra distance to get us here. And that distance is 6.814012. And so that's going to be approximately 19.95. So now we know, okay, at 13.14 seconds and at 19.95 seconds, we're going to be at 20 feet. We have two more spots to figure out here. There we go. So we've got the times for these two. We still need to find the height or the times for these two spots where we're also at a height of 20 feet. And so the way we do that is we just take our first ones. So this is x1. Nope, sorry, that's not x1. x1 is there. This is the height for the max, so x max. So x3 is x1, but a full cycle later. Or in other words, 32 seconds later. x1 was 6.32339 seconds plus 32 seconds equals 38.32339 seconds. And for x4, we just do the same thing. x4 is a full cycle after x2, so it's 32 seconds after x2. And we said x2 is 19.95 seconds plus 32 seconds equals 51.95 seconds. And so therefore, we can reach our conclusion. The times you are at a height of 20 feet are 6.3 seconds, 13.1 seconds, 38.3 seconds, and 51 point. Sorry, not 13.1. 19.95, which is actually 20. But I think we rounded up to 19.95. So it's actually 19.9 seconds. And then 51.9 seconds. Okay. So there we go. As you can see, these questions can be a little bit involved. You have to, first of all, go through all the work of building the model. And that's usually the trickiest part. And then once you have the model built, then I find it's really helpful to draw a diagram of the function and figure out what points I'm trying to find. Am I trying to find the x value or the y value? And then from there, it's a lot of just that grade 11 solving sine equations and so on. So hope that was a useful example for you. I'll stick around for about 30 seconds, take any questions. If you don't have any questions, if you can just put a 1 in chat. I think I'm going to give you questions 2, 3, and 4 from the homework to finish up. Okay, so again, just please give me a 1 in chat if you are feeling like you've understood what's going on, and feel free to ask questions if you have them. Thank you, Daniela. Ramaisa, how about you? Did that make sense? Do you have questions about it? Great. Okay, so then I'll see you both at 2 p.m. There'll be a post in the classroom that has the link to the Google Meet for you to join for the assessment. Have a great rest of your day.